Okay, so today we're going to continue with exercise 215, which is something that builds a lot on what you did in 214. And I recognize right now in part 1 I refer to exercise 211. Remember, I changed the order a little bit and I forgot to change it here. It should be 214. That's what you did last class. Today's where we really get into how to make one of these models, how to make the sides and that sort of thing. So it's kind of the critical piece to this whole puzzle. Certainly critical for your assignment 202. What you're doing today will directly apply to assignment 202. So if you spend a lot of time and do a good job, it'll make assignment 202 that much easier. It does take a little bit of getting used to and grasping, but I think you'll be able to get there. I am going to today do what we did last class live, then do what we're doing today, and then also do what we're doing on Wednesday. So I'm going to do the whole spectrum all the way through the end because I want you to at least see where we're going. Then I'll come back on Wednesday and I'll do the last portion again. So if you get a little bit lost at the end, that's okay. But for those people that are kind of pushing ahead, I want to do the full spectrum so you can see the whole process. Okay? So it'll take me a little bit longer to get through it that way, but I think it'll be more valuable to see it as a whole. So what I'm going to start with is back in the world of SketchUp, getting the topography. I've already got this particular piece, but I got it by going to the add location and then selecting a location. This is again in Yosemite, and then I showed the terrain by going to File, Geolocation, Show Terrain, which lets me see that there's my piece of terrain. That's what I'm going to be working with, and that's what I'll ultimately be creating a model out of. So I have that. I made sure that I saved it as a SketchUp 7 file. So I went to File, Save As, and I chose SketchUp version 7 when I saved it, and there it is on my flash drive. All right. Now this is in feet and inches. So when I move to Rhino, I want to make sure my default units are in inches, which they are in this scene. I can confirm that right down here. It says inches. I know it's behind me, so you probably can't see it, but it does say inches. I know my units are correct. And now it's a matter of bringing in that topography from SketchUp. So I'm going to go to File and then Import. And I'm going to bring in that. The default options are just fine. And it's going to come in. Now, I have the little person, which I really don't need, so we can go ahead and delete that. And if I zoom out a bit, there we go. And zoom selected. We can see that there's my piece of terrain. I can also see it in the top view, zoom selected there. So I see it in both directions. All right, looks like it should look. I'm happy thus far. Okay. So what I'm going to do is clean up my layers just a little bit. Remember, we had the Google Earth layer, layer 0. That's fine. That can stay. The rest of these really I can get rid of just to make them a little bit cleaner. So let's get rid of all those. Okay, so then I need to make this a live NURB surface, which is exactly what we did last class, and I'm going to do that by using the contour command. So I'm going to create a new layer called contours. Now remember, I'm going a little bit faster through this part because we already covered it last class. So I'm going a little bit faster, then I'll slow down when we go through the part for today. So I have this as contours. I'll make that the active layer by double-clicking on it, and then I'm going to cut contours of this object. So I'll go ahead and type contour, or it's under curve from objects, contour, right there. And I'm going to select my base point. Let me turn on knot and vertex so I can select, hopefully that as my endpoint there. And we're going to go in this direction, and I'm going to do it, we'll try 100 feet and see how it looks. All right, reasonable. All right, I'm going to repeat the process, but I'm going to make sure that instead of selecting the contours, I'm going to go back and select the surface. And I didn't select both. It's only the surface. So if you get points out of this, you selected the lines, not the surface itself. So I'll right-click to repeat the last command, which is contour. I'll select that point again. And, oops, I didn't quite select it. There it is. No, come on. There we go. And we're going to go off in this direction this time. Again, 100 feet, and we'll divide it up that way. All right. So now, if I turn off layer 0, which is the terrain itself, I get just the contours in both directions. There they are. I need to do a little bit of trimming to clean those up. So I'm going to trim with this this, this, and no, it's going to be this one. Alright, and I'll go up to Edit Trim, or I'll type Trim. Let me make this big for just a second. And we'll go ahead and go through and get rid of these extras. Alright, now that I've gotten rid of those nice extras, we have a nice solid line that goes all the way around my object. Now I can make it an actual surface. So let me go ahead and create a new layer, and we'll call this layer Terrain. If I can type. There we go. I'll make that active, and then I'm going to do a curved network of these contours. So I'll go up to Surface, Curved Network. If I did it correctly, I should get A, B, C, and D. I'll go ahead and say OK, and now we have to wait for a little bit while this processes. All right. Remember that once it creates the surface, it's going to be running really slow because it's a very dense surface. We need to rebuild that so that it's not so dense. So I'll type rebuild, and we'll make it like 100 by 100. I'll go ahead and say OK. Alright. So now let's turn off the contours, and I have my nice surface that is a NURB surface ready to go in Rhino. And now we kind of begin with what I was going to work with today. We did do a little bit as a prelude to what we were doing today, last class, where we cut the topography lines and then we projected them. We're kind of doing that same thing, but we're going to be a little bit more specific with how we do it today. Okay? So what we're ultimately going to be creating is something like this, right? And the size is going to vary. Our laser cutter bed here at school is only 12 by 24. So creating something 11 by 17 is kind of about the max that's easy to do. So everything that I have set up is designed for 11 by 17, but if you wanted something bigger than that, obviously you could build two of them and glue them together, or you could go somewhere that has a bigger laser cutter and do the same operations just on a larger scale. Okay? So what you're doing in this class is one of these two sizes. The 11 by 17s, if you don't have a particularly hilly region, can be nice. Sometimes they're a little bit better even if you have a hilly region because you have a little bit more space to deal with. You can do it at a larger scale. Which size you create, I really don't care. This tends to take 3 sheets of cardboard as opposed to this one, which takes 2. Or if you're buying them at the store, this would be 1 sheet bought at the store. This would be 2 sheets bought at the store. Again, we're talking, maybe $3 a sheet. So it's not going to break the bank, but there is some financial difference to which size you pick. Okay? So the other thing that you'll notice is on the handout in exercise 215, it's also in your book. There's this handy little chart that I made that will help you kind of figure this stuff out. Okay? So the first thing that we're going to look at when looking at this chart is that we have on the first 2 columns the drawing units and the actual feet. This can translate really nicely into scale. So for example, if I wanted to make a model that was an 1/8 inch equals a foot, you can see down there, there's something on the first column that says 1/8, right? The next column would be 1 foot. That would be an 1/8 inch equals a foot. So everything in that column is geared toward that particular scale of final model. Okay? So because of the size of this terrain, it's actually going to be a little bit bigger in its scale. And this is you're going to have to determine what scale is appropriate for your particular piece of terrain, right? Because everybody's terrain is different. I can't script it and tell you which size to pick. Okay? For this particular piece, 1 to 200 is actually a good scale for me. So I'm going to do 1 to 200. Again, it's going to be either specified by some instructor when you're doing an architectural project. I need a topography model at 1 to 200, or at an 1/8 inch equals a foot, or whatever. Or you're going to have to determine, based on the size of your lot, based on the size of the laser cutter bed, what's the appropriate scale. Okay? So because I've determined already that 1 to 200 is about the max scale that I can do, right? I'm going to look as we go over in that same column. I have the laser bed of 12 by 24, which would be the equivalent of 2,400 feet by 4,800 feet, right? The model size that I want to create is actually 11 by 17, which would be 2,200 feet by 3,400 feet. Does that make sense? How I'm following across there? Okay, so what I'm going to do is in the top view, I'm going to draw a rectangle, and I'm just going to pick the regular standard rectangle. that is, right, 3,400 feet. Here, I should be at 3,400 feet, comma, 2,200 feet. Okay? And again, this rectangle is going to vary based on the scale that you choose and the size of the terrain that you're working with. Okay? It's probably, in all likelihood, going to be one of the top 4 or 5 in this list. That would be my guess. Okay? But again, you're going to have to try it. And the easy way of doing this would be to pick the rectangle tool and start at the first one, 1 to 500. Oh, this would be 5,500 by 8,500. So I can say at 8,500, comma, 5,500. And I'll hit enter. Oh, that was in inches, not in feet. Sorry. One more time. At 8,500 feet, comma, 5,500 feet. Wow, that's way too big. Obviously, I don't have enough terrain for that. So then I move on to the next size, right down, which is 4,250 by 2,750, right, which is again going to be too big for my particular piece. And then I wind up with what is the correct scale here at 1 to 200. Okay? So again, it's going to vary based on your particular piece of terrain, and there's no way for me to tell you what that's going to be. So now what I'm going to do is I'm going to move this, right, which represents the final model, right, is ultimately going to represent this. I'm going to move it where I want it to be on this piece of terrain. And sometimes it's helpful to switch from the top view into kind of a shaded view so you can see, oh, the canyon is kind of over here on the right, right? I want to include the canyon. So I'm going to go ahead and move this, and we'll move it up, and then I'm going to move it over to include that part of the canyon. Okay? So if I look at this in the perspective view, we see that I have, right, a piece of kind of my terrain outlined there, and that's the size that I'm going to ultimately make in my model. Does that make sense? Okay? So the next thing that I need is I need these lines to be on the terrain itself. So I'm going to use the project command, which we've done before, to make these lines exist on the terrain. So let me create a new layer before I do that, right? And we'll call this model border or something like that. Again, there's no right or wrong answer to what you call this, but I'll call it that. Right? Then I'm going to go ahead and switch into the top view, because remember the projections have to occur in the top view. And I'm going to type project. Oops. My keyboard is sticky today. And I'm going to specify, right, select curves. It's going to be that rectangle. There it is. I'll hit enter. Then I'm going to project onto the surface. So I'll select the surface, and I'll press enter. And when I do that, we see over here that I get a really nice outline, right, on my terrain of what my ultimate size here is going to be. Does that make sense so far? Yeah? Okay, so now I don't need the surface that's outside of that line. So let me go ahead and switch for just a second into shaded mode so we can see it a little bit better. And I'm going to go ahead and trim. So I'll type trim, and I'm going to trim off this outside surface so I end up with just the piece of surface that's going to be my model. That's it. Okay? So that's done. I can actually go ahead and get rid of that line because I don't need that line anymore. Right? And so now I have this perfect piece of surface that's going to ultimately become my model. Okay? So the next piece of the puzzle is I need to figure out, at my particular scale, what are all of these contour intervals, right? What's the thickness? And so in order to do that, I need to really understand the exact measurement of what material I'm going to make this model out of, right? So we're reverse engineering what this contour should be. So if we do it out of standard corrugated cardboard, right? This is available at the bookstore. It's the one that's, you know, kind of in the architecture section. It comes in sheets. I think they're like 24 by 30 sheets or 30 by 30 sheets or something like that. If you're doing that and you got out a really fine measuring device, you would find out that this is 5/32 of an inch thick. Okay? So it's not an eighth, it's not a quarter, right? We need to be very precise about it. So 5/32 is what this is. If you do it out of mat board or some other material, which is perfectly okay with me, you have to go measure that exact thickness of material, right? The same thing would work if you wanted to cut it out of plywood, right, and you knew the thickness of plywood was whatever it is, right, you could then apply the same rules. Okay, but for what you're going to be doing, in all likelihood, you're going to use this cardboard, right? It's really cheap. So 5/32 is the magic number. So I'm going to come back over to this little sheet here, right? And I'm going to look in the contour material thickness category, right, which is the second half of this table, and I'm going to look at 5/32 of an inch, right? So that column, as I come down to 1 to 200, sorry, I have to do this not above you here, 5/32 of an inch is going to be 31.250 feet. Okay? So I have to make my contours in the z direction at 31.250 feet so that they end up the right thickness for the material that I'm going to make the model out of. Okay? So I'm going to use the contour command. Once again, select objects. It's going to be my surface here. And actually, before I do that, I'm going to create another. Well, no, it can be on the model. That's fine. Well, we'll do another one here. We'll call this model topo. Make that active. All right, so I'm going to use the contour command, which is under curve, curve from objects, contour, or I can just type contour. Select the objects. It's going to be the surface itself. I'll go ahead and hit enter. Contour base point. Doesn't really matter what point I pick. I just want a point on it. So we could try to pick the low point here, something like that. Right? Now it needs to go up in the z direction. So I'm going to make sure that I go into one of the side views and that I'm going up straight in the z direction. Right? If it's off, you're going to get contours that aren't correct. So we're going to go up in the straight z direction, and my distance between contours is going to be that value, which is 31.250 feet. So 31.250 feet, and I'll go ahead and hit enter, and it's going to cut a bunch of contours for me. Like that. Okay? So now if we look at this, I'm going to go ahead and turn off my terrain. We're starting to see, right, the makings of what's going to make this. Does that make sense so far? Okay? So again, thickness of the material decides what the actual contour interval is going to be, and that's where this chart comes in handy, right? So you're going to want to save this down the road. That's why it's in the book, so you won't lose it, right? I promise you it'll be useful. Could you figure it out mathematically? Yeah, I just did the math for you, so you don't have to. Okay? All right, so now we have the makings of it. We have all the contours, but what we need to do is to create the sides that step up and down. Right? So that's the next big piece of the puzzle. And there's two different ways of doing it. One way I think is significantly easier in the long run, but it takes a little bit of practice to get it right. The other way is a little bit easier in the short term, but long term it's going to be a big hassle. Right? And so I'm going to show you both ways as an example, and I'm going to work on the less dramatic side here for the first method, and then I'll do the other one on the far method. So I'm going to go ahead and create a new layer, and we'll call this stepping 1, right? And that's just for the first side. And I'm also going to change the color of this for right now so that it's red, so that I can see that these are separate. And so in this method, what I'm going to do is I'm going to click on the point tool here so that I can create points. And actually I'm going to pick the multiple point tool, which is a right click on this. And I'm going to set a point at each, let me turn off vertex and not, at each endpoint. Turn off everything except endpoint. And I'm going to go up the side creating little points. At each of those intervals. Okay? So I've gone ahead and I've done that. I'll hit enter to be done. And there they all are. All those little points. And what I'm going to do is I'm going to select these points like this, not the lines. And I'm going to rotate 3D starting with this point. So I'll do rotate 3D. Oops. Starting with this point here along this axis from straight up to be folded over on the side. And you see when I fold it over on the side, we can kind of see where the steps are going to be. Does that make sense a little bit so far? Right? This, by the way, these methods are all written out in the physical modeling tutorials. 6.1 explains it. And so what I'm going to do is then draw, using the polyline tool, the steps. So I'll start at the first point here, and I'll go straight until I get to, let me turn on a couple things here. We need to turn on point snap. There's point, right? And you see how when I kind of get close to it, then I snap. Let me turn on perpendicular too. There. There's perpendicular. I can go up to the next one. Perpendicular. And we trace it along like this. Yeah.
So in this method, there is no overlapping between two layers to make it more durable as material. So like when you add the layers, the only supporting is on the side.
It's on the sides, exactly, exactly. And you can see it on this, that it's only, and so they overlap on each other and then sit on the sides, right? In a cardboard material, it's durable enough, and you're welcome to come over and feel these. It's definitely durable enough, even if it was bigger, right? If we look at this one, for example, it's still very durable. If we started to get really big, maybe we would get a little borderline in this thickness, but it's still generally pretty good, pretty lightweight. If you were doing it out of like mat board or something much thinner, you may need to cut it twice and glue them together and stack them or something to get a little bit more durability out of it. So anyway, I'm going to continue working my way up the sides here. All right, and I get to the end, and I generally like to leave one at the end just a little bit long. Right, that's just to help me long term. The other thing that's going to happen is I know I'm going to end up stepping down, but we can deal with that part of it later. So now I'm going to take my line, and I'm going to rotate 3D right from my point again, right? Same axis, and I'm going to fold it back up to be vertical, right? And now if we look at the side, right, it's stepping very nicely at each of those points. Okay? It's relatively easy to do it that way. It's going to be a little bit more challenging doing this side because it's such a dramatic contour, but at the same time it could be done. Okay? So for me, however, the faster method is to use something that's called a C-plane. And if you've worked in AutoCAD before, it's like the UCS system in AutoCAD where we can change what is X and Y, right, temporarily. And so what I'm going to do is I'm going to change, right now X and Y is in what's called the world top. If we look at my little coordinate system down here, we see X going to the right, Y going up, and Z going straight up that way. So it would be X and Y. So the plane that I'm working in is in the X and Y plane. That's my primary plane. I want to switch it so that the plane is now working vertically in this direction. So we'll do a new layer for stepping 2, right? I'll make that active, and I'm going to change my C-plane by going to this little triangle, and I'm going to go to Set C-plane, and World Top is always the default, right? So you can always jump back to World Top. I'm going to do it with 3 points, and so I'll select 3 points, and it doesn't really matter which 3 points I pick, but I generally like one of the corners as an easy way of kind of setting it up. So I'm going to go ahead and click on that corner, and it's going to ask me first direction of the x-axis. So I want the x-axis to be going out in this direction, so I'll go ahead and click, and we can kind of see right there's a little red line representing the x-axis. Right now the y-axis, it wants me to go in the normal x and y axis. I instead want that to go up where the z was, so I want it to go straight up. So I'm going to use one of my views here to specify that this is going to go straight up now. And you see that my grid changed from being flat on the ground to being up in plane. Right? So now what I can do is, without rotating, no rotate 3Ds or anything, right? Let me change the color so that we can see this on the screen. I'm going to go ahead and go to my polyline tool, and I'll start at my first point, and I can go ahead and just draw this in place. Which to me is a lot faster long term, and it eliminates the need to do those rotations. So I'll pull that along like so. And I'll continue going down that way. When I'm done with this, I do have to reset my C-plane from being in this direction. I'll go back to this little triangle, and I'll go to Set C-plane World Top, which resets it to what it was, right? And then I can move on and set the C-plane again for each side. I would do that adjustment for each side. I do it for here, I do it for here, and obviously I'm doing it in the front. So it's a separate operation each time, always going back to World when you're done. Okay? So what I'm going to do is I'm going to pause the recording for a little bit. I'm going to get myself through the rest of these sides, and then I'll show you the last half of it so that you have the trajectory of where we're going. All I'm asking you to do today is get to the point where you have the stepping sides. Okay? And get as much of them done as you can. Okay? Are there any questions up until this point? Yeah?
Why does each side need to be separated?
They don't ultimately have to be, and actually we're going to end up putting them on cut layers and engraved layers. I find that it helps when you're creating them to have them as separate, especially if you create the points, because you're going to end up with tons of extra points. And it gets confusing as to which points are which points. Right? So I'm fine if you do a stepping sides, especially if you're doing the C-plane method where it's all one layer. It's perfectly fine. Okay? Any other questions? No? Okay. So I'm going to pause the recording, get myself through the rest of these steps, and then I'll show you the balance of it. In the meantime, you guys should start getting to this position.